Here we go. In 14.5, the worksheet is going to ask you problems that are going to ask you to add or subtract rational expressions. And they're basically two types. The first type are the ones that have the common denominators. Those will be your first few problems that you have to do. And the second group of problems will be the ones with uncommon denominators. You will spend most of your time dealing with the uncommon denominators because these ones are considered a whole lot easier, in my opinion, than these ones down here. When you are adding and subtracting rational expressions, what you have to do is determine what you're going to do based off of their denominators. I would recommend that sometimes you factor first. And when I say sometimes, it just depends whether the denominator is a monomial, like this, or whether it's a binomial that's not factored. It's hard to know what makes up number 23 when you look at its denominator. You may or may not know what it has in common until you factor it. You're lucky on some of the problems they have it factored for you, so you don't need to worry about that. If it's a monomial, it doesn't matter. But sometimes you will need to factor first to see what the denominator is made of for problems that are not factored, that are trinomials. So, if they have common denominators, you add or subtract their numerators, and your common denominator doesn't change. I always go back to things like when you do 1/2 plus 1/2, it equals 2/2 or 1/2. Your numerator plus your numerator stays in the numerator, but your denominator stays the same because this denominator is what you're cutting it up into. It's 1/2. 1/2 plus another half is 2/2. The halves doesn't change. Some people get the rules for multiplying and dividing confused with adding and subtracting, but hopefully that makes sense to you. Keep in mind, the denominators don't change when they have a common denominator. When they don't have a common denominator, you're going to need to multiply by the missing factors over themselves. Technically, that means we're multiplying by 1. We're trying to create a common denominator so that we can then just put the numerators together. I also put in your notes to assume that the binomials in the fractions are in their own group, meaning if you're trying to find a common denominator between, let's say, an x is in one denominator and an x plus 2. Let's just say I was looking at these two things. Your common denominator is not x plus 2. Your common denominator is not just x. It is whatever this group is, an x by itself, and whatever this group is. The common denominator would be x times x plus 2. I'm just going to put that this is your LCD right there for now. And that's because if this is a binomial, it's its own group. This does not have an x plus 2 next to it. There's nothing I can multiply this by that's going to make it an x plus 2. Keep that in mind. Too many students try to think, oh, I could just multiply by a plus 2. It doesn't work that way. That would be 2x. 2x is not the same thing as x plus 2. So keep in mind, this is what your common denominator would be. All right, with that being said, I have 3 examples for you today. The first one comes from the first group, which it even tells you in the directions that they are like denominators. Perform the indicated operation and simplify. In this case, you could reduce, but if you did, then you wouldn't have a common denominator anymore. So in order to subtract, you need to look at the two denominators first and foremost, and you have to decide, do they have a common denominator? Are the denominators exactly the same thing as each other? And if they are, then what can you do? You just subtract their numerators. That's what I tried right here. Add or subtract the numerators and put over the common denominator. So number 4 is as simple as this numerator subtracted by this numerator over the common denominator. Can you put these together? They are not like terms. They're not multiplying each other. You're subtracting the 4 from the x. It stays like this. And then, can I reduce? No, you cannot reduce because the x is in a relationship with this 4 with that minus sign. It's in a group. Do not reduce here because it's not a group of multiplication. Down here it is, but up here you are subtracting something which makes it its own group. You can only reduce if there was an x minus 4 in the denominator that's being multiplied by the other groups. So this is what I would leave my final answer as. It's over a common denominator, and that's as low as it's going to go. You could split it if you wanted to, but it's really not going to be any more simplified than what it already is. Okay? So there we go. We're going to leave that as our answer for number 4. Numbers, I can't remember if this was 18 or 16. I think it's 18. Is that 18? Thank you, Ms. Porter. Number 18, unlike denominators, it says it in the directions. It even tells you the denominators are not the same. Perform the indicated operation and simplify. So, you look at your denominators. You're supposed to subtract this thing from this group from that group. And when you look at it, this has a 5, this has an x, 5 times x. This has a 5, and this has an x minus 4. So when I say we need to multiply by the missing factors over themselves, what you're going to look for is what would my common denominator be? What can they all go into? And you need basically one of each type of factors. Let me show you what that looks like in this problem. This has a 5. That's one factor. This has a factor of 5. They both have a factor of 5. I don't need to worry about that. That's a part of my LCD. I'll put it off to the side. 5 is one of them. This has an x. This does not have an x by itself. It needs an x on this side, because an x is a part of my LCD. That's all that's on this side. On this side, I have an x minus 4. That's its own group. I need an x minus 4 as a part of the factors that make up the lowest common denominator. My LCD should be a 5x times an x minus 4. So what that means for this problem is I'm going to need to multiply this fraction by the missing factors over themselves. This will make it 5x times x minus 4. Technically, I'm multiplying this fraction by 1. And this fraction, I'm going to multiply it by an x minus 4 over an x minus 4. That way, the denominator will be 5x times x minus 4. And then this denominator will be 5x x minus 4. My common denominator is 5x x minus 4 for both fractions now. I'm going to put this minus sign right here like that. You also need to remember that x minus 4 times x minus 4, you need to FOIL that out. That's this times this times this times that, this times that. I've been doing this for a long time, so I know what that's going to be in my head. X squared minus 8x plus 16. If you need to FOIL it all out, put it together, put the negative 4x and the negative 4x together, you'll get negative 8x. Trust me in this case. Minus 12 times x. Notice I'm not going to FOIL out the denominator. There's no reason to. This lets me know it's already factored. I have a common denominator. Now this becomes a problem just like we did up above. All I have to do is take this numerator and subtract this numerator and put it over the common denominator. I have x squared minus 8x plus 16 minus 12. 12x. Thank you very much. That's what I meant to say. So when I put this minus 12x, it's going to combine with that negative 8x, and I see x squared minus 20x plus 16. Now, I've played around with this a little bit, but let's see if you think of the same thing. What multiplies to be 16 but adds to be negative 20? You have 4 times 4. You have 8 times 2. You have 16 times 1. Those are the only factors that would multiply to become nice and even, right? Do any of those add to be negative 20? Is there any way to get to negative 20 with that? So this does not factor further. You should always check to see if it factors. It may or may not. We tried to factor it just in case, because the people who wrote your test are going to want you to see, can you still simplify it after you're done? The people who wrote these questions in the textbook, they were just giving you some problems. The reason why we did not FOIL out the denominator was if the numerator factors and the denominator is factorable, you might be able to reduce it. So we leave it factored just in case it might reduce. Keep that in mind. Lastly, 23. These two do not have a common denominator yet. But I don't know what this bottom one is over on this side until I factor it. What are its factors? If you know what this factors to, why don't you tell the person you're sitting next to what would go in the parentheses? Go ahead and discuss that real quick. I am hoping you said x minus 4 times x minus 4. Because that multiplies to be a positive 16 and adds to be negative 8. When you look at that, I now know what missing factors I need in order for them to have a common denominator. This fraction, this left fraction is over x minus 4, x minus 4. The right fraction is only over an x minus 4. Not the same denominator. I need another one. So we multiply by something to get a common denominator. What are we going to multiply by? An x minus 4 over an x minus 4. Technically, we're multiplying by 1. In this case, we're going to make 1 the same missing factor over itself. I am not going to FOIL out the denominator because it's already factored, and maybe after I combine my numerator, maybe it will reduce. But to put this together, what I'm going to do is I'm going to take this positive 12 and I'm going to multiply it to this x and that minus 4, which is going to make it 12x minus 48. Since I have a common denominator, I'm going to put these two things together. And I get negative 3x minus 48 over my common denominator. I'm going to look to see, does this numerator factor? And I see a GCF. I can factor out a negative 3. When I factor out a negative 3, I know that would be an x plus 16. And what I'm looking for is, will this reduce after I'm done? Sometimes it will, and sometimes it won't. In this case, since this doesn't factor further, it's not a perfect square and a difference of squares, this is my final answer. I recommend leaving all your answers in factored form. It will make your life easier, and it shows me that you tried to see if it could reduce. We'll stop your notes right there.